Okay, day one of 1-5. We're going to start by talking about just kind of rational zeros for now. Remember, the word rational basically means it can be written as a fraction. So a rational zero, for example, could be the number 2. I could write 2 as a fraction. It's 2 over 1. Or even 1/3. That would count because 1/3 obviously is a fraction, right? But now you start talking about numbers like, say, the square root of 2. That's not rational. Because you can't write that as a fraction. A lot of times you want to look at the decimal. If the decimal repeats or terminates, you can write it as a fraction. If it goes on like gibberish, like the square root of 2 does, then you cannot write it as a fraction. So right here, all I want you to do is list all possible rational zeros for each function. Those of you that had me for Algebra 2, this is called crisscross. Okay? That's what we did for that, and there is a reason we do crisscross. But the first thing you want to do is make sure that it is in descending order, that is by powers. So is example 1a in descending order? Yeah, it's to the 4th, to the 3rd, and then has a constant. Okay? You do always kind of want to use that constant to do crisscross. If there isn't one, you have to work with it. And basically all you do is you take that leading coefficient and you draw an arrow that way, and you take your constant and draw the arrow that way. There's your crisscross. Okay? And all you do is you look at the number 5 right there, and then over here you put all factors of 5. And then we kind of do a little bit of a cheat, but let's just face it. If you take 1 times 5, do you agree that you get 5? Are there any other rational numbers that you can multiply together? Or we'll just say factors of 5. Let's leave it at that. Anything else? Not really. But what about -1 and -5? Can I do that? Yeah. And so we kind of cheat, and we just kind of do this. We just say positive and negative for all of those. Right? How about 3? 1 and 3, but also -1 and -3, right? But again, we're just going to cheat. Now you might wonder, well, why do you do the crisscross? Why do you put all those numbers on the right and all the other numbers on the left? Well, the reason I do that is basically what you're going to do now is you're going to take all these numbers on the left and put them over all of these numbers on the right to create rational numbers. Okay? So for example, I need to take 1 and put it over 1. Well, that is 1. Take 1 and put it over 3. That is 1/3. That's what I mean by over, as in a fraction. Okay? Then I have to take 5 over 1. Well, that's just 5. And then 5 over 3, which is 5/3. Now, right now, would you say that we have 4 possible rational zeros? Those could work. Again, the word possible is in there. Those might work. Those have a chance. There's actually 4 more. Yeah, all negatives. And again, we just kind of cheat, and we just say, well, forget that. I'm not going to sit there and write this out all day, and you just do something like that. Okay? Obviously, we go on to school, you got to do whatever that professor says, but that's good enough for us right now. So basically, those are all 8 rational zeros that could possibly work for that function. We know they don't all work because it only has 4 of them. Are we guaranteed that any of those are counted towards that 4? No, they don't have to be. They could be. All 4 of them could be in there. But again, all 4 could be imaginary. We don't know. Okay? We're trying to get a list of ones that could work. Okay? Why don't you try that process on 1B right now? Again, this is listing all possible rational zeros. Well, hopefully that was enough time for you. So 1 and 2 over there. Sometimes you'll notice I won't even write the plus minus at this middle level. I'll just wait till the bottom and just write it down, because let's face it, you don't really need it anywhere before then. But hopefully you took your time. 1, 8, and 2 and 4. Very good. If you got it going a little too fast, well, maybe you might have forgotten 2 and 4. Are there any more for 8? Any more factors? No, that's it. So now you got to make sure you take every one. So 1 over 1, that's 1. 1 over 2, that's 1/2. 2 over 1, that's 2. 2 over 2. Do you need to write it again? No. Is it okay if you do? Yeah, that's fine. But basically I took, here I'll put a different color in there. I took 1 over 1, I took 1 over 2, we're doing good. And then we went and took 2 over 1, and then, well, when we did 2 over 2, that's just 1. We already have that. You don't have to write it again. So now let's go 4 over 1. Well, that's 4. And then we'll do 4 over 2. Well, that's 2. We already wrote that one. So you don't have to write it again. 8 over 1. Well, that's 8. 8 over 2, that's 4. I already wrote it. So how many possible rational zeros does this particular function have? It has 10 of them. Okay. So if you were asked to find the rational zero of that function, would it be wise to try 6? Is 6 going to work? It has no chance. Is there any guarantee that 4 is going to work? No, but it could. It at least has a chance, where 6 has no chance at all. So why even try? Okay. On the next couple examples, hopefully I can make a distinction between rational zeros and what Descartes' rule of signs gives you. Okay. So first, let's just have a nice review, and let's just kind of do Descartes' rule of signs on this one. And maybe we'll just do it off to the top over here, because sometimes it can actually be very helpful. Okay. So if we go ahead, we know that it has to go down in order, which it does. And remember, with Descartes' rule of signs, you don't have to worry about zeros because they're not positive or negative, so it doesn't matter. And so is that a sign change? No. Is that a sign change? No. Which basically means for positives, I have to put none. Well, that's kind of nice when stuff like that happens. So then you go and do your negatives. Well, this would be negative x to the third, because if you put negative x in there and you take it to the third, do you agree it would end up negative? Okay. If I put negative x right in there, well, that's going to be negative 6x, correct? And then plus 20. How about sign changes here? No? Yes. So there's 1. So we know that 2 of them must be. And how do we know there were 3 total? Well, x to the third. Now, let's just do the crisscross then, and I'll show you what or how Descartes' rule of signs can be helpful. Not always, but can. Now, 20 is a little bit bigger number, right? But what's really nice is the leading coefficient, or the one way out front, is 1. What are the factors of 1? Well, 1. Okay. Factors of 20. You're there. Okay. So the nice thing about this is I have to take all these numbers on the left and put them all over 1. So basically when there's a 1 out front, basically these are your possibilities, right? But of course, plus or minus. So according to crisscross, there are 12 possibilities, correct? Now realize Descartes' rule of signs talks about all zeros, whether they're nice rational ones or irrational or imaginary, right? It talks about them all. So that negative that you see in there, it says there's going to be one negative answer. Is there any guarantee that that negative has to be rational? No, it could be negative square root of 3 for all we know. But we know for a fact that none of them, no matter what, are positive. So would we have to try all 6 of them? Or all 6 positives? You have to try those. You can, but guess what? They're not going to work. So all we really have to do is try the negatives in this problem. And I'm going to show you a couple ways of doing that. Of course, one way is to try, and let's make sure I don't do the right answer first. All right. You could try a -1 like this and see if it goes in there, right? That is one option. So you go like this, and you go 1. I'm waiting to see what I should write next. 0, very good. 6, 20. Now, if it does actually go in, there is actually a 0. We know that the remainder would be, here, let's just do it quick. 1, -1, -1, 1, 7, -7. Uh-oh. So is -1 the answer? No. So what I would do is just, maybe list all the possibilities and just kind of cross them off as you go. So that's one way you could do it, right? So -1, shoot, you're out of there. Now what I'd like it to show you is how the calculators can speed up this process a little bit. This is what synthetic division. We also have synthetic substitution, correct? Calculators are really good at substitution if you use them right. Even those little ones can do this. They just do it a little bit differently. Those TI-30, X2, whatever other letters and numbers they put on those things. Okay? So let's go ahead. Let's just look at this one. This is the one that I'll use, so I got to get out of there. And probably would have helped if I would have wrote down the equation. What do we got here? X to the third plus 6x plus 20, correct? Watch how I do this. And what one do we want to try? Let's try -10, right? Because nobody wants to do -10. That's huge, right? So you go like this. You go negative 10. And I want to take that to the third power, right? Plus 6. And then you got to put negative 10 in there as well, right? This is basically doing the substitution. In fact, I think this is how I saw some of you doing it for the quiz. Plus 20. Are we in agreement? That's how you could do that? Now, obviously, one way we could do it is distribute all the numbers to everybody, right? That's one way you could do it. But I want this, when I hit enter, I would like it to say what? And no. Just right there, exactly. Yeah, it was so close. Now, on the 83s or the 84s, here's a quick way to test your next number. Because we tried negative 10, right? What's our next choice if we work our way down is what, negative 5? You notice how I kind of dismissed negative 20? You know, you could try it, all right? But I kind of dismissed it. So you keep working your way down. So here's what you can do on these calculators. On the TI-30X, whatever those are, you just hit the up arrow, and it will let you go change those numbers. On these, you see how right above the enter button it says entry in kind of blue? On mine, on yours it's that peach color or whatever you want to call that. So just hit second and enter, and it brings all that stuff up so you can just change the number. So all I should do then is go back. Should I change the 20? No, but I should change this negative 10 to a negative, what's the next one? 5? Negative 5, but do I want negative 50? So how do I get rid of that? Yeah, delete, right? And then you just kind of working your way over. Okay, this has a little delay. Hopefully, let's see how close I got. All right. Negative 5. Delete. So do you see how you can just go up there and change those numbers and then just hit it again? A little quicker, right? Works pretty fast, pretty slick. Is that working on the TI-30 whatever? You just go up and change the number, right? How about negative 5? Does it work? No. Oh, gosh. But we're getting closer, right? Our y value is getting closer. So how did I do that again up here? Hit. Second. Enter. Let's try, oh, I don't know. Let's try negative 2. And you try negative 2. You just keep trying them. And we find, oh, it's 0. Spectacular. What that means is that negative 2 is actually one of the zeros, right? Because the y value ended up being 0. So you go back here and you say, all right, I know for a fact that negative 2 is a rational 0. But it says all rational zeros. Well, guess what? I found one that happened to be negative, right? Remember, that one wasn't guaranteed to be rational. But if I know the other two are imaginary, should I keep looking? No, you can stop. That's it. That's the only one. It's the only one there can be. Now, is Descartes' rule of signs always going to be this helpful? Unfortunately not. Because remember, Descartes' rule of signs is talking about all numbers. Rational, irrational, doesn't matter. Okay? Where the crisscross is just talking about rational. So, well, what do you do if it's not helpful? Well, I'll just put up Descartes' rule of signs here real quick for you because I don't want to use up time doing that. But the use of it, I do. So 3, 1, 1, 1, 0, 2. For one, do we know which row is actually going to happen? No, we don't. And we don't know, it says 1 in the negatives, though. That's very promising, right? But remember, you're not guaranteed that that negative is one of your rationals. Okay, so that's where you have to kind of, try and figure out what's going on. Well, let's do the crisscross and find out what our options are. Well, once again, that's a 1. Well, now we got a few more. So we'll put the plus minus out right away. So obviously 1. Does 2 go into it? How about 3? 4? Yep. How about 5? Yep. 6? 7? 8? Okay, so now we're kind of just pairing them up, right? Here they are. So it's going to be 4 and... Now, more than likely, what are the chances 40 is actually going to be the one that works? Pretty slim, right? Chances 20 is going to work? Probably pretty slim. What I normally like to do is start with the small ones and work the way up. Okay, because I think it just saves you a lot of time, because normally they are going to be in the first half. Not all the time, but normally they will be. Okay, just based on how the functions are made. And so at that point, when you're working with other people, I'd say kind of divide them up a little bit, because we are looking, basically, there's possibly 4 of them. Okay? So we wouldn't know. We'd have to keep trying. Okay? Or one thing you could do, it's up to you. You could always just sit there and go back to that calculator and keep typing them all in. How many we got to try? 2, 4, 6, 8. We got to try 16 of them. You know, if you want to try all 16, that's fine. Or here's what you could do. You could start trying some. So do you want to try some negatives? That's probably not a bad idea, right? So what do you think about, oh, I don't know, -2? Let's say that was just your favorite number and you wanted to try that one again. Then you could go 1, -6, 6, 24, and -40. Again, that other way still works. That substitution way would still work if you want to do it. So we got 1, -2, -8. So far, this isn't really looking overly promising, is it? So 16. And 22, right? And -44. It's kind of looking horrible, isn't it? -20. Oh, 40. Look at that. It worked. So we found one of them, -2. Okay. So would it be wise to continue to try all the negatives? No. You know there's only one. You don't know it's rational, but you know once you find a negative, there are no more. So stop trying them. Okay. So what I'm going to do, and what's funny is you can actually try from out of here now. Right? This is what? X to the 3rd minus 8x squared plus 22x minus 20. Do you agree all the other 3 zeros are still in here, aren't they? So you can just try taking them out of here now. Can you still try and take them out of the original? Sure. But why not just take them out of something smaller? So why don't you divvy up the positives here, and we'll go. Let's just kind of forego some of these, though. So somebody already tried +1. We know it's a no-go. All right. So let's have this row over here to my right try +2. This next row right here try +4. Next row try +5. Next row over there try +8, and then +10. I'm just going to tell you those two don't work. I tried them. They don't work. Okay, apparently someone's trying to tell the +2 row that they better get it to work. I'm getting some mixed signals over here. I don't know. All right, here we go. So we were given a huge hint by the other half of the class row that has +2 that it should work. So I would still do it like this, and I'll show you why in a second. Do you have to do it this way? No. You can still do it the synthetic substitution way, but you might like what happens at the end here, and it kind of helps you speed things up. So we got what? 2, -6, -12, 10, 20, 0. So apparently the other side of the room was correct. That +2 works. The only problem is, do we know which row we're talking about yet? We have found a positive, correct? Is it possible there are 2 more positives? Well, then obviously we could check with the other rows and say 4, did it work? No. 5, did it work? Oh, 8, 10. Okay, so basically we know it doesn't because we worked as a team. But what if you had this one on your own? Well, you could look down here, right? This is basically x squared minus 6x plus 10. Your goal in this class, whenever given a polynomial problem, should be to get down to x squared. Because once you get there, you've got quadratic, you've got key number factoring, you've got difference of 2 squares. We spent at least a month to 2 months in Algebra 2 solving quadratics. You have a lot of methods to use. So you try it. Now, what are we looking for here? We're looking for rational zeros, which will only come from rational factors, which means it better key number. If it doesn't, are they rational? No, they're not. So all you have to do is try. So it has to multiply to be 10 add to be negative 6. Do such numbers exist? Okay, they do exist, but are they rational? No, I can't think of two rational numbers that'll make that happen. So are they rational zeros? No. So have we found all rational zeros? Yeah, they are. Negative 2 and positive 2. What's funny is now most of you think we already know which of the two rows happens. We still don't. If you went through and did quadratic, would you then know which of the two rows happened? Yes. But is it still possible that there are two more that are just irrational, like square root of 2 and square root of 7? We don't know. Or they could very well be imaginary. But really, for this problem, based on the directions, we don't care. Okay? We just want rationals. Okay? Are there any questions?